So I'm going to try and zip through this. This is 2018 foundation paper for Unit 3, Year 10. Your formula sheet here, which I'm going to park down by there. And the first question is, red Martians invade Venus using X-ray guns. They've put it backwards here. So you got starting with gamma, which is high frequency short wavelength. So they got high frequency short wavelength. These got low frequency long wavelengths. So from knowing that, you would know from these words by ear that increasing frequency goes this way. As you get up to the gamma end, it becomes more dangerous. Name the EM radiation labeled A. So this was infrared. Red Martians invade. Name the ionizing EM wave. That is radioactive. In some radioactive materials, it's going to be gamma all the time. Even though X-ray is damaging to your cells, it's not the radioactive part. And state why ionizing, this one, radiation is dangerous. Like I just said, they damage cells and they can mutate your DNA. So I'll just put that there. This one's on circuits then. This simple series circuit, it's telling you there's series. So you could do the SCS, series current same. And you know that the current's going to be the same through all of this. Use this R, so total resistance there equals R1 plus R2. So there's 1. And there's 2. So 2 plus 6 gives me 8. It's as simple as that for 1 mark there. Use an equation from page 2 to calculate the current. So I'm looking for current. Well, the only one really, it's not the only one because that one's got current, but this one, because I've got voltage over resistance there. And I've just calculated my resistance tonight to be 8. So my resistance is 8. My voltage then, is it unknown? No, there it is, because it's right on the top of the battery there. So it's going to be 12 over 8. Gives me 1.5 amps. State the current reading on ammeter 2. Let's have a look. Well, if it's 1.5 here, it's going to be 1.5 there and there and there and everywhere around here. So it's going to be 1.5 there as well. Because in a series circuit, the current is the same everywhere. Now the 6 ohm resistor is removed and it's put in parallel. So you can imagine this fella now. They bring it out and they put it below it. What's going to happen? The resistance is now going to decrease. That's what happens when you put it in parallel. So therefore, the current is going to increase. If you drop that resistance, you're going to increase the current. Hiya, sir.
Hi, Mr. Timothy.
Okay, back there after a little disruption. Sir came in to have a look. But I'm going to try and continue with the pace to get through this in one video. So the question is a typical conduction, convection, radiation question. And if we look at this wall, they've stuck foam, a solid foam inside. So the fact that it's solid is going to be, you're going to be dealing with conduction. The fact that it's foam is going to trap pockets of warm air for convection. And then you've got this shiny surface there, which is going to link the radiation. So this is my model answer, because it's also asking for 6 marks, explain why heat is lost. So you need to put something about like heat is lost when it moves from a high temperature to a low temperature. So you need to include something there for the 6 marks. And then I've mentioned the cavity board is made from a solid. It's made from foam, so it's a good insulator, which means it's a poor conductor. So this is going to reduce heat loss via conduction. The shiny surface is a good reflector and a bad absorber. This is going to reduce heat loss via infrared radiation. And then my last point there, that foam board is filling the gap that would otherwise be between the wall, which will be filled with air, which is a fluid. Therefore, it's going to reduce heat loss via convection. It's going to trap pockets of warm air. So that's your 6 marks there. Then we've got this table. So no previous knowledge required here. It's all numeracy. You're just recognizing the patterns. Oh, sorry, before that, we've got payback time. And then it comes to this question. So I'll do payback time. Pork turnovers cause salmonella. So your PT equals C over S, which gives you for your mid-terraced house, your cost of installing it is 385. So your cost on top. And then your savings per year is 110. And when I bung that into the calculator, it's going to be 3.5 years for 1 mark. Your second mark, then, you are disagreeing because this statement is saying that this house is longer. Well, it's actually this one's longer. So that's why I'm disagreeing there. And then we come to that table, which I think for 2 marks is lovely. If you can recognize this pattern, so 5500, I've got 1100, and then I've got 4400. What's the pattern? It's going to be this one, take away this one, gives you that. So I can do that for the bottom easily, 2440. Minus 440 gives you 2000. And then this one, you can see to get to 3000, I need to take 640 away to get to 3000. That's 2 marks. And then use information to give the house that's got the smallest impact on the environment. Well, you can see the carbon footprint is really low compared to this one for your mid-terraced. So that's why I've said mid-terraced, because for 2 marks, carbon footprint is small. So let's park that up there. Lovely question here, where you just read in the balance for the mass, 59.4, it's right there for a mark. And then the length of the cheese cube, you can see there's 3 centimeters, and it's even giving you the units there. And then to get the volume, it's going to be length times width times height. Easy for you to say. That's 3 times 3 times 3 is going to be 27. Don't put 9. It's not 3 plus 3 plus 3. It's 27. And then you need to use that equation. That's density. I've written a little p there, but it's rho. Anyway, we won't get into that. 59.4, which is my original mass. My mass on top, volume on bottom, which is 27. It's going to give me 2.2. And then my unit is the hardest one. It's grams per centimetre cubed, look. Because it's divided. So it's grams per centimetre cubed. Oh, wrong one. Let's go there. It suggests doing it twice. Why is he doing it twice? To calculate. What does that say? That should have said mean. That looks like mice. Yeah, that should say mean. Because I've rushed this. Check repeatability. So remember, repeatability is when you do it again. Reproducibility is when another group does it, your method. And then you can identify anomalous results. I'd say that's probably a bigger answer there than calculating mean or whatever I've written there. I don't know what I've done there. State how the measurements could be improved. I could use a better resolution. So I'm going to go from centimeters to millimeters would be better resolution there. If I'm dealing with temperature, I could have been going from 1 centimeter to maybe 0.1 centimeter. It's a better resolution. 2 marks, so I need 2 ticks. I've not ticked any of these because it's dealing with a third. And when I look at my diagram, there's not a third of anything there. Okay, it goes from 1 into that, and then I've got halves, but I've not got thirds. If there was thirds, you'd see maybe another one of these. So I've not ticked anything with a third. I'm happy that the 3 pieces of cheese, or all pieces of cheese, has the same density, which it has, because it's going to go to the mass volume ratio. The mass of the large piece of cheese is half the mass of the original. Seems about right. So this is half that. And then the last one's wrong because it says the mass of volume ratio to for each of the 3 different samples is different. It's going to be exactly the same. Okay? And you've got these 2 there. You've got these 2. Oh, this one. The diagram shows an electric hand dryer. It's 230 volts. It tells me that there, and it tells me that there. And I've got a power of 2600. Complete the following. AC, alternating current, continuously changes direction. Okay, it doesn't change frequency, and it doesn't change speed. Then, for 3 marks, I think there should be a 4 marker, but it's 3 marks. I've picked my time is 15 seconds. My power is 2,600 watts. And it says, calculate the energy. So I need to go to my front sheet. And energy equals power times time there. EPT. So I got, you can see I made a mistake there. When I cover up my energy, it's just P times T. So power times time is 2600 times my 15. That's going to give me 39,000. Now, you can see that I wrote that in, ready for joules, and then I realised that it's the hand dryers used for 6 times. So I need to now times that by 6 to get my 3 marks. And that gives me 234,000 joules. Nice easy question, and for 2 marks, it wants you to calculate the current, and it's giving you the formula. So current equals power. Well, we know our power is 2600 from up here, and our voltage is 230. If I just show you that there's your 230 volts. And I'm just plugging numbers in here, using my calculator to give me 11.3 amps for 2 marks. Okay, practice these. They're going to come up. I should leave that out really because I think I need it. Alright, the hand dryer is connected to the mains. 3 core cable is standard. Complete the table. So the live wire is going to take current and the neutral wire is going to take current at what you just calculated there. The live wire is going to take current at a high voltage and neutral wire is going to take current at a low voltage. So don't get confused here and think, oh, this current is going to be close to 0, because it's still the current. It's the same value of current. It's just, it's taking this one at high voltage, this one at a low voltage. The earth wire, if it's operating normally, is not going to take any current at all. That's why it's 0. And it says if a fault develops there, how does that RCCB, the residual current circuit breaker, how is it going to protect? Well, it's going to detect the current difference between neutral and live wires. That's the big difference between MCB. It's kind of like your fuse, where it detects that current surge, but it doesn't protect the user. It only protects the circuit because it takes a while for that current to surge. Whereas the RCCB protects the user because it detects small fluctuations in that in the current between the 2 wires. So this is a much safer unit to use. This is much safer. And if you were asked advantages over of an MCB over a fuse, MCBs can be just switched back on. Okay, you don't actually melt any wire there. This one, a salesperson suggests that if he halves the wattage, or the power, we should say, and double the time, he's going to get a better energy efficiency. Well, that's nonsense, because if we half the power, even though we're bringing this back down, we're doubling the time. And you can see when I plug it back into the calculations, instead of doing 2600 times 15, I'm just doing 1300 times 30. So it comes out to be exactly the same. So he's not correct there at all. How are we doing? 12 minutes. So I'm going to rush through this one. This, if you want more detail on this, this is going to be in the video for hire. This is 386 if you wanted the code to that, and you could watch me go in a bit more depth this. But you need to know what a transverse wave and a longitudinal wave is. There it is. Vibrations move at right angles to the direction of the wave, or the direction of the energy of the wave. Don't just put vibrations move at right angles, because at right angles to what? This everyone gets confused by, because they think V equals 3.13 square root of D. Oh, I'm not even going to attempt that. But when you actually look at the values here, it's not that hard. Like this is the square root of D. So your value for this one is 1.87. So V equals 3.13 times 1.87 to give you that. And then you just need to do a bit of rearranging for this one. So I'm putting V on top, because 3.13 and square root of D are tied together. That's going to give me those results. The graph is going to look like this. And I've also given a nice scale there. This one here is true, because when the depth is 1, the wave speed is 3.13. When the depth is 4, the wave speed is this. And you'll see by times in 3.13 by 2, you're going to get 6.26. So that's very true. And then the last question, to make this one video, I know I've rushed this last bit, use the graph and the equation this for calculating the wavelength. So I've gone to my graph there, and I've got that value. When it was 2 meters deep, I've gone up and I've come back, and you can see that it's around about 4.5. They'll give you marks if you're off that as well. So when it was 2 meters deep, it was 4.5. Frequency is constant. It's 0.2. And then when I do the calculation, frequency on the bottom, wave speed on the top, gives me 22.5 meters. Chris now suggests that as depth increases, the wavelength decreases. Well, that's not true, because as the depth increases, the wavelength must also increase, because the speed is increasing, and we can see that from this graph there.